In this video, we're going to look at angles that are formed when two lines are cut by a transversal. So basically what that means, if you look, I have three lines in the picture. This line right here is called a transversal. And what a transversal is, it's just a fancy way of saying a line that's intersecting two or more other lines. So this is the transversal. So it's just a line, but we call it a transversal because there's two or more other lines that are intersecting with it. So when we have a picture like this, there's a couple different things you want to know. So the first thing is going to be talking about the interior versus the exterior. So when I talk about the interior, I'm talking about this space right here. So this would be the interior because it's between those two lines that are being cut. And then the exterior would be here. So that's one side of the exterior because it's outside of the two lines. And then this would also be the exterior. So let's go ahead and just label those. So this is an exterior, interior, and then exterior. So whenever we have a diagram like this, you're going to hear things like alternate interior angles, alternate exterior angles, corresponding angles. So let's go ahead and look at what do those actually mean. So down here, vertical angles, if you remember, vertical angles always occur whenever you have an X. So in this picture up top, we actually have two X's. We have this X right here. So where we have 1 and 3 are vertical, 2 and 4. And we also have the X down below. So you don't have to have a diagram where you have two lines being cut by a transversal to form vertical angles. You just need two intersecting lines. But in this picture, you do have two sets of vertical angles that are formed, or two X's that create vertical angles. So remember, vertical angles, non-adjacent, so they're the ones that cross from each other. So it's whenever you have two intersecting lines, and it's the angles that are across from each other that are congruent. So these two here are congruent, and those two are congruent. So they're always congruent, no matter if you have this picture up top or you just have two intersecting lines. So if I'm looking at the picture up top, I already stated angle 1 is congruent to angle 3. Those are vertical. Angle 2 is congruent to angle 4. Those are vertical. Angle 5 and angle 7, those are across from each other, and then 6 and 8. So the next set of angles that we're going to talk about only occur when you have a picture with two lines being cut by a transversal. So meaning you have to have a picture similar to this, two lines and a transversal. So the first set we're going to talk about are corresponding angles. So the way I think about corresponding is I think about corresponding as it's what matches up with each other. So angles, they're going to be angles that match up where they're in the same position when you move the top part of the diagram down. And I'll explain what that means. The top part of the diagram down. So they're the angles that are in the same position. So that's another way to think of it. Angles in the same position. They correspond with each other. So if you correspond with something, they match up. They're in the same position. So if we look up top here, if you imagine taking this whole top part of the diagram and just sliding it down, 2 would overlap with 6, 3 is going to overlap with 7, 1 will overlap with 5, and 4 will overlap with 8. So that's what I mean when I say angles that match up when you move the top part of the diagram downward. It's the angles that overlap with each other. So 2 and 6, 3 and 7, 1 and 5, 4 and 8. Or you can think of angles that are in the same position. So this, if you look at just this section, top right corner is 2. This section, top right corner is 6. So corresponding angles, I'm going to go ahead and just list out the examples here. So we had 2 and 6. So angle 2 and angle 6. Notice I'm not saying congruent here. I'm just listing them because They're not congruent unless the lines are parallel, which we're going to talk about later. But for right now, we're just looking at which ones are corresponding. So 3 and 7. So you're just putting an and between them. Angle 1 and angle 5 match up. So angle 1, angle 5, and then 4 and 8. So the next set of angles we're going to talk about are alternate interior. Now, to me, those are a lot easier to identify because if you just look at the words alternate interior, think about what they mean. So alternate are going to mean opposite sides of the transversal, so alternate sides of the transversal. Interior means they have to occur in this yellow region. They have to be in the interior. So 3 and 5, they're on opposite sides of the transversal, and they're in the interior, so they're alternate interior. Same thing with 4 and 6. Those are opposite sides of the transversal in the interior. You can also see kind of like a Z shape here. I'm going to erase this in a minute, but you can kind of see this Z shape. That's how you can also look for alternate interior angles. So for a Z shape or even like a backward Z, so almost like an S for 3 and 5, that's another way to identify alternate interior angles. So let's go ahead and write our definition for that. Alternate interior, so they're going to be inside and opposite sides of the transversal. And our examples were 4 and 6 and 3 and 5. And I'm also going to just write like the Z shape for these. So then the next ones are alternate exterior. So they're going to be opposite sides, but they're going to be on the outside. So the only difference between alternate interior and exterior is inside versus outside. So outside and opposite sides of the transversal. So if we look up at our diagram here, 1 and 7 are both in the exterior and they're on opposite sides of the transversal, and 2 and 8 are going to be alternate exterior angles. So 1 and 7, and then 2 and 8. And then the last set here are same side, interior versus exterior. So again, it's basically telling you exactly what it is just by the name. So same side, interior, they have to be inside and on the same side of the transversal. So it'll be very similar to thinking about alternate interior, but instead of opposite sides, they're going to be on the same side. So if we go up top, looking in the interior, same side of the transversal. So here's your transversal. So if we're looking at the transversal, same side of it would be 4 and 5, and then 3 and 6 are on the same side. So 4 and 5. And then 3 and 6. And then the last one, same side exterior, well, they're going to be on the outside because they're exterior. And then they're going to be on the same side. So very similar to alternate exterior, but instead of being on opposite sides of the transversal, they're going to be on the same side. So if we look at our picture, exterior, so in the green, 2 and 7 are on the same side of the blue line, the transversal, and then 1 and 8 are on the same side and both in the exterior. So we have 1 and 8, and then 2 and 7.